Good afternoon, everyone. Thank you for coming to our May RTD webinar. We've got a very interesting topic for today's webinar. We've got two presenters with us. So Scott Greenow, who's the Executive Director of Freight at Transport for New South Wales, and Brayden Soo, who's the Manager of Freight and Supply Chain with the National Heavy Vehicle Regulator. So thank you both for taking the time out of your day to come and present to us on some important topics. And Scott, I know you think you've done 2 or 3 of these now, so thank you for being a repeat offender. We certainly appreciate your support. Look, I'll let Scott and Brayden speak to their topics themselves. And Scott's going to kick things off. We do have the option or functionality rather for questions. So if you have any questions as we're going through, please do put them either in the chat or the Q&A function that we've got set up for this meeting. We will have dedicated time at the end for any particular questions as well. And I'll just keep an eye on that as we're going through. So look, I might pass straight over to Scott to get things started. Yeah, Scott, over to you.
So, thanks, Josh. I'm just sharing my screen as hopefully everyone can see a presentation.
Yep.
Excellent. And thank you again for the invite to come back. I don't often get a repeat invite, so I appreciate that. And thanks to everybody for dialing in to have a bit of a chat around what the future looks like for innovative vehicles, in particular in New South Wales. I just need to reiterate how critical this relationship is for us from Transport for New South Wales with IPWEA and the local councils, and of course with NHVR. But from a road manager point of view, it's a reminder that we never forget, and we remind everybody that 90% of the New South Wales road network is owned and operated and managed by local councils, and those road manager decisions are critical for how freight moves across the road network in New South Wales. So as the slide says, I'm the Executive Director of the Freight team at Transport. We look after effectively how everything except people move across the network in New South Wales, but very much focused on road freight, rail freight, and efficiency at port, as well as urban movement of goods. So it's a broad remit. Make sure I'm pressing the right button. Of course, I would like to pay my respects to the traditional custodians of lands from where we're all dialing in from. I'm in the land of the Directorate people, so I pay my respects to elders past and present and extend that respect to any Aboriginal and Torres Strait Islander people on the call today. So I will go through slides quickly, and I'm not intending to read them out to you as much as possible, so please make the most of soaking them up as we tick through. But you can see that freight is a vital part of the economy. It is 9% of the gross value add for New South Wales. However, it's not just an economic element. It is the movement of goods is what keeps our communities alive and thriving. So it is a critical part of what we do. The real big takeaway from this slide is that 28% growth. So this is 482 million tonnes through to 618 million tonnes is our estimate of where that's going to be by 2036. But just to flag, we are halfway through that already. We have already seen massive growth in the movement of freight in New South Wales. And while population will increase, and as the slide said, freight does follow where people go, but we're also finding that our buying habits as a community and as a state are changing, and all of a sudden parcel deliveries and just in time and individual consumerism is really taking a significant increase into that freight space for what needs to move on in particular the road network, given that the road network is what does our last mile deliveries. So we're at a bit of a crossroad, to be honest, and we can maintain the status quo, which will lead to, as the freight task increases, leads to more trucks, more fuel, more road wear, more exposure to the impacts of heavy vehicles moving on the road network. And all that means from a road safety point of view, from a congestion point of view, environmental point of view, etc. Or we can take another path, and that is where we rethink how we do things, look at innovative, higher productivity vehicles that make fewer trips, that use less fuel to move the same amount of payload over a task, less impact on the road network, which translates to less maintenance draw on our ever insufficient budgets for being able to keep assets available and in fit for purpose state. And of course, you end up with better road safety and sustainability outcomes. Now, being at a crossroads isn't new. There was a time when we, as a community, it might not have been us as individuals, but people face this similar people in our roles face this question some time ago. So circa 40 years ago, there was the concept of B doubles put forward. And we rarely look back to see what the outcome of decisions has been. And realistically, this is what it translates to. If we were moving the amount of freight that we do now, but we didn't have B doubles, we didn't take that step, then we would be looking at an additional, you can see the additional trips of 4.6 million trips of semi-trailers to move the same task that we move today. So that is a significant increase in heavy vehicle movements, pavement wear that comes with that, the fuel use that comes with that, the road safety risk, et cetera, et cetera. So we've already hit a crossroad in the past and made some smart decisions. And this could be similar to where we moved to triaxle groups, for instance, and ended up with more payload per truck with that reduced pavement wear in comparison. And if we think that that wasn't an option, if you look at the US, that is the scenario that they play there. So semi-trailers with tandem axle trailers. So vast increase in the number of movements in comparison to what we do here. Even when you pro-rata it based on the amount of ton kilometers that we do versus what the US do. So if we now teleport ourselves into the future, we've got the option here of looking at how do we use smarter, more innovative vehicles better. Now, this is the ultimate outcome. So you see a PBS level 2 performing, so keeping in mind that a 26 meter B double performs equivalently to a PBS level 2 vehicle. But with some smart design, we could get a BAB quad, which is effectively 2 sets of B double trailers that perform at level 2. Now that level 2 vehicle or BAB quad may not do every delivery that a B double does today, because they might not go into the locations, even though they can fit through the streets and through the intersections and handle the curves and grades, et cetera, et cetera. They have all the same performance as a 26 meter B double. Just because of operational elements, operators might use smaller vehicles because of the nature of it. You can't use a B double to deliver to a supermarket, and you might not use a BAB quad to do some of the task. Excuse me. But there is the opportunity to look at these in a comparison way. So the BAB quad could do most of those long haul journey, but when it gets to the end destination, it's still able to access the same locations that a 26 meter B double could. So at some point in the future, we could be sitting doing a presentation like this saying, well, we would have had an additional 11 million truck trips per year if we hadn't have made smarter decisions back in 2026. So we're at that same kind of concept of, well, what do we do next and what's the impact of that? So when people see bigger trucks, they often think, just instinctively, a human would look at a truck and go, well, I think a truck is bad because it's big, so a bigger truck must be worse. And fundamentally, the physics don't play out that way. They are all of the impacts that most people worry about from a truck is actually offset or improved by a higher productivity vehicle. Now, when you overlay all of the safety equipment that we require for those vehicles, then you start to get an even greater outcome. And I say that because average ages of heavy vehicles in New South Wales are circa 15 years. And 15 years ago, we didn't have the same safety technology. So if you have any of these heavy vehicles that are then mandated, innovative vehicles mandated with safety tech, they just a couple like autonomous emergency braking, lane keep assist or lane departure warning, and electronic stability control. Those three technologies, the studies in Europe have found that those three technologies combined reduce the risk of a heavy vehicle being involved in a fatality by 35%. If you're then reducing your exposure to those heavy vehicles as well, then you start to see measurable changes in road safety outcomes as well. But this is looking at this one from an ESA point of view, or equivalent standard axles, which is our best measure of pavement wear. On the left, you can see the pavement wear impacts of these B doubles, of these combinations. When you compare the modular B triple versus the B double versus the semi trailer, which is general access and doesn't need to ask us for access at all, you can see a significant increase in ESA or pavement wear per ton of payload. And that's ultimately what we're measuring against, because the task will happen. The goods are moving because they have more value in a location that they are in a different location than where they are. So the goods still move, they're needed to move. But if we don't embrace high productivity vehicles and innovative PBS vehicles, you end up forcing industry to choose the poorer outcome for us as well. So you end up with significantly more increased pavement wear for the same task. You can even see from a congestion point of view that, and it's a bit difficult to sometimes get your head around as to the 0.73 meters per ton of payload, but that talks about the road space that you have in a vehicle. So if you're moving the same amount of freight, if you're in less productive combinations, you need more space for prime movers, you need more space for gaps between trucks, etc. You're introducing more people into the, so that's decision making, human errors, fatigue, drugs and alcohol, speeding, just mistakes that people make. All of those things contribute to greater congestion, more safety risk, more pavement wear, more impact on our road networks in our communities by using vehicles that are not as productive or as safe as the options that we have in front of us. So hopefully this slide makes some sense, but happy to speak to individual elements or during the questions or individuals after the session as well. But from a policy and strategic direction point of view, New South Wales is well set up, in my opinion, and I am biased because obviously my team led the development of this heavy vehicle access policy. But this was released in September 2024. And as the cover says, safe, sustainable and productive road freight, they are three pillars that are not individual targets. We require the outcome, all three outcomes, when we are considering improved access in New South Wales. And typically a more productive vehicle with smarter decisions around things like safety technology, emissions standards, etc. But a more productive vehicle will deliver inherently improved safety and sustainability outcomes. So if we be smart with our decision making, we can get the very best of those three outcomes. The part of the puzzle that isn't printed on the front cover but is just as important is that what we're looking at is how do we get to that safe, sustainable, or safest, most sustainable, most productive world for road freight without throwing additional cost onto governments and additional cost onto industry that isn't offset by a commercially viable productivity gain. And that is an important part of what is shaping our thinking of how this is done. So it's not just about how do we make sure we don't charge industry extra money, because they will, in this approach, we will require them to have better designed vehicles and they cost more money. And we will require them to have better performing, safer technology, satellite tracking, etc., smart onboard mass for particular vehicles. And that all costs more money. But when you consider that these vehicles can be 65% to 100% more productive than the vehicles they're replacing, then that is significantly in the commercially viable space. So we are offsetting some cost to industry with significant gains in productivity. But those gains also come with benefits to road managers and asset owners. So as I said, reduced fuel use, reduced emissions, and very importantly, reduced maintenance on the road network and reduced requirement for investment to enable the access for those vehicles. So we set the performance of the innovative vehicles against the capability of the road network, as opposed to our traditional method where we require our roads to be upgraded to enable poorer performing but higher productivity vehicles of the past. All right, achieving higher productivity productivity with better vehicle performance. I did go touch on this, but this is where we effectively, and when we do road manager access decisions, we are in essence taking the performance character or the characteristics of the heavy vehicle, including performance, including axle spacings, mass, length, height, width, etc., every element that we can determine of how that vehicle would interact with our road network. And then we compare it against the capability of our road network. Now, if the performance of the vehicle fits within the capability of the network, then happy days, we can say yes. If that doesn't, then we might have conditions to allow them to travel, or it might be that we say no and we require upgrades to our road network. So what we're doing is kind of short-circuiting that approach and saying to industry, here is the capability of our road network. Come to us with a vehicle that meets your operational requirements, but also fits within the capability of our road network, so far as performance, so far as axle spacings and mass, and how it interacts with bridges, how it interacts with rail level crossings, how it interacts with rest stops, etc., what kind of reduction it makes in pavement wear, and all of the different things that we need, safety outcomes, sustainability. And we provide that avenue for industry to then be able to deliver the vehicle that meets the needs. Now, that is a really effective way for us to minimize our investment requirements in the road network and our maintenance requirements, our ongoing costs. It's a very effective way of us delivering outcomes for road safety, for our communities, for environmental improvement, it's etc. It's a balloons fall from the sky. But the other side of that coin is that significant investment from industry means that they need to be able to use their vehicles commercially across viable networks. So if I compare a 26-metre B double access today, it has very viable network in New South Wales. It's probably really captures the freight network in New South Wales. There are other roads that freight travels on, no question of that. But it is where most of the high productivity vehicle movements are because that's the network that's approved for B doubles. And it's made up of about 40,000 Ks of local roads and about 20,000 Ks of state roads. But if you then have a vehicle that is much longer, still meets all of those requirements, then that is the type of network that we should be trying to target so that that vehicle can commercially be used as widely as possible. And remember, every trip that one of those vehicles takes, it's reducing all of the impacts that heavy vehicles and the movement of freight on our roads has on our roads and our communities. So it's in our best interest as well. So there are other elements of performance of high productivity vehicles that I think, as I might have said earlier, that this is most of the things for performance and heavy vehicles is a little counterintuitive. We often see, as I said, a big truck and we think it's bad because if we have a crash with it, then it's a really poor outcome for a light vehicle. So if we see a bigger truck, then it must be worse. It must perform worse. It must be more dangerous if it's involved in a collision. But what we see here is a really great example of where an innovative vehicle that is longer and able to carry more freight, more payload, is able to, and if I'm looking at the diagrams at the top of the screen there, the 30-metre BS level 2 A double versus the 26-metre 9-axle B double. Even though the A double is 30 metres, so 4 metres longer and able to carry more freight than a B double, it is able to actually move through the network with a better low-speed swept path. So it can manoeuvre through tighter intersections than the 9-axle B double and be more productive in doing that. We also have, I think, fair to say, the understanding of as heavy vehicles get bigger, people lose sight of the benefit of additional axles, and particularly as you get multi-axle groups. So whenever you have a triaxle group or a quad axle group, what you have there is an axle that is still designed to the same capability and capacity of every other load carrying axle in the combination, where you have a single axle or a tandem axle, so two axles. They're still designed with the same capability, same ability to carry weight, same ability to brake the vehicle and retard motion safely. Except because of the way axle masses work, each of those individual axles are only required to carry less mass compared to tandem axle groups or single axle groups. And it's in the realms of, for a single axle, it's maybe 9 tons. For a tandem axle, it's up to 8.5 tons. But when you get to triaxle groups and quad axle groups, it can be down to 6.5 tons of mass that each of these axles are carrying or less. And that means that when they are required to do a braking task or when they are interacting with the pavements, they are a lot more gentle on pavements and they're a lot more capable at pulling the vehicle up. So the axle groups, the multi-axle groups, are more stable because they have a wider, like a broader footprint, more rubber on the road, spread across a bigger area. And they also have the ability to brake at the same capability that every other axle does. They're just required to slow down less mass, so they're more effective in that braking. So these vehicles often can outperform vehicles that look to be much smaller and are combination-wise much lower masses as a combination, but you still have equivalent performance, and that's covered in the ADRs as well. So the Australian design rules require each and every component, including the prime mover and the trailers and rigid trucks, to meet braking standards for each component, which then added together means that the vehicles are able to safely move through the network without introducing additional risk. Where they then start to control or mitigate more risk is those safety equipments that we talked about. So these are newer vehicles that have the safety technology required, so autonomous emergency braking, and even not just crash prevention, but harm minimization technologies as well, like side underrun protection. So light vehicles and vulnerable road users are unable to get under the truck and then be run over by the axle groups, which is where most of the real devastating outcomes can occur. So this isn't a new thing. We have done this process before and we've proven that it works. This is an odd looking vehicle. It kind of looks like someone's taking the B-double trailer, the lead trailer, and just hooked 3 of them up, and that's effectively what happened. So this is a 27-meter B-triple, and it's purpose built to carry tunnel lining segments for Snowy Hydro 2.0. And as you can see, this truck saved 65,000 freight movements through Cooma and on the Snowy Mountains Highway. So it was able to perform the same as the vehicles that were in the corridor already, was designed purposely to be able to interact with the infrastructure, including the bridges and the road network, etc., but just significantly more capable and productive while reducing emissions and exposure to driver fatigue, etc., etc. I promise you I'm almost done. This is my last slide. So this is really just a call to arms that there is a significant opportunity for us to be smarter about how we work with the road freight industry and how we make the most out of our road networks, how we minimize the impact on communities of the movement of goods, how we maximize the benefits of the movement of goods, so economic viability and competitiveness, lower cost of living, etc., improved environmental outcomes, improved road safety outcomes, reduced maintenance wear on roads, reduced need for upfront infrastructure spend for network upgrades, better, more reliable networks because we have alternatives in case we're impacted by natural disasters. All of a sudden, these vehicles are able to perform at so much higher productivity, but able to perform at better standards so they can use other road networks temporarily in natural disasters instead of being required to park up, etc. There is a massive opportunity here, and it's something that we're very happy to work with councils to support how these vehicles can be best used in your area and how they can be promoted so that we get access for these under notice. That makes it as easy as possible for industry to invest in these smarter vehicles. And as I said, that gives us the very best outcomes from a road manager point of view. So I think I have gone over time. Apologies for that, but I will pass back to Josh.
Thanks, Scott. No, I appreciate the presentation, and yeah, we've got a bit of time up our sleeve. There's one question that came through, Scott, that I might throw to you now just because it's topical. So Luke said, has the trade-off for longer vehicles having to take longer routes been analysed? They are seeing a reduction in freight on some roads where longer vehicles aren't suitable and an increase on others due to their suitability for longer freight. So this could result in moving more freight through rural towns, for example.
Yeah, it is a really good question, Luke, and it's kind of the crux of what innovative PBS vehicles are about. So just because you get longer in this context, it doesn't need to change your performance level. So moving to a longer route isn't necessarily required in that case. So it's about designing vehicles that are purpose built for the network as it is. And if they already go a particular route, but they require PBS level 2 performance to be able to access that route, then it's saying to industry, you can have higher productivity vehicles, but they must meet PBS level 2 to be able to achieve that network and that access. So it's really designed to try and mitigate that risk, because at the moment, our traditional approach is that we go, well, yes, you can have a high productivity vehicle, but because that vehicle doesn't perform as well, it's going to have to take a really long route that ends up maybe leveraging local road networks through towns and, as you say, through parts of the road network that we ideally wouldn't want them on. But this is about getting smarter, better performing vehicles to do the same tasks that we're doing today.
Right. Thanks, Scott. Look, I've had one more question come in as well, which I might quickly get to, and Brayden may actually have a comment on this one as well. But questions from George Robius. He said, while ESA has been a measure for pavement damage for many years, it only takes into consideration vertical damage. Has the recent heavy vehicle damage analysis taken into consideration the shear load from moving the vehicle through the drive axles, and especially roads on grades?
Yeah, it is a good question. And ESA, it's kind of like the comments that they say about democracy as a form of government. ESA is what we have at the moment. So it's the best that we have available to us. So far as horizontal pavement wear, PBS is certainly working towards making sure that, and has some performance elements around that. What we are striving towards, and we've got it in our policy where we are pushing to trial technology as soon as it's ready, and it's that we're hoping that will be very soon, is looking at powered trailer axles for exactly that reason. There's a number of benefits that come with powered trailer axles. They'll be new to the market and they'll need ADR changes in the near future, but they are able to spread that horizontal, that motive power through the combination. They're able to make a vehicle that performs better while having lesser impact on the road network. They'll also be safer under braking. Some testing shows that they might even save up to 50% fuel use for a diesel powered prime mover attached to the front. So there is massive opportunities, but all of that comes with us looking at these issues and technology in a way that leverages everything available to us, and keeping in mind that it's not just about safety, it's not just about sustainability, it's not just about productivity, it's also about minimizing costs to government and industry. But we can't just look at any one of those individually. We need to try and achieve all of them wherever we possibly can. And look at the best way to do that.
Yeah, great. Thanks, Scott. Brayden, did you have any additional comment on that question at all?
Probably two things. So one of them is just piggybacking off what just Scott mentioned, how we're working with the jurisdictions at the moment on an alternative means of calculating horizontal forces when it comes to PBS vehicles. So completely understand the point that vertical loading is only one of various ways of looking at pavement where there's horizontal and torsional forces, things like that. And there's a lot of complexity when it comes to those forces because, tire contact width, the inflation pressure, friction coefficients, even the pavement types, all these things have a significant influence on the materiality of the pavement wear. And I think the difficulty is how do you equip people with the information and the tool set to actually undertake those calculations to make a determination on what may or may not be good for your network. So to that end, that goes to my second point where I think it was only recently Ausroads have commenced a new project, the effective higher axle loads and pavements or something along those lines. And part of the scope of work for that particular project is actually recognizing the problem raised in this particular question is how do you actually deal with horizontal effects when it comes to calculating the wear caused by freight vehicles. So hoping the outcome of that particular project is it provides a benchmark method or a way of viewing it that's actually implementable and practicable to actually do those calculations.
No, thanks, Brayden. I appreciate the comments. And look, Brayden, that's probably a good segue into your part of the presentation. So I might hand over to you now for your presentation to the group.
Excellent. So today I'll be going over a tool set which was released a few months ago, which will help with providing some of the numbers behind decision making, which might input into access decisions, policy related decisions, or in some feedback we've received might play in information which might be beneficial for case studies for cost benefit analysis and submissions for funding. So we have the NHVR Freight Pass tool. It's a tool that the NHVR developed. My team, Freight and Supply Chains, we worked with external consultants, WSP, including their pavement engineers to develop this tool set. And the whole point of this is in strategic alignment with what Scott basically said is Australia, we have a number of priorities we need to seek to achieve, net zero, vision zero, as well as how we deal with the significant productivity issues that Australia needs to overcome. And as far as the NHVR is concerned, that's part of our remit, is how do we deliver safe, productive and sustainable heavy vehicle movements, recognizing that all of these are a trade-off and different vehicles might perform in different ways. What's difficult is trying to understand between especially now with modern heavy vehicles and how innovative and how weird and wonderful some of them can actually be. There isn't necessarily the information available to allow road managers or other people in government or even the community to understand the numbers and say, well, what's actually more safe than another vehicle, what the relative difference is in terms of carbon emissions, or even what it means when it comes to vehicle exposure and number of trips on the network. So we developed Freight Pass to try and plug this particular problem statement on how do we understand trade-offs associated with vehicles when given our current vehicle configuration categories, the axle types, which we're now seeing in the system like split axles. If you Lego piece all those variations together, there are over 11 million possible freight configurations that a road manager engineer or someone in government might need to understand, well, what does this actually mean for my network? And what does this mean for the broader system and its externality impacts on the community? So we felt that not only do you need to develop a tool which allows those calculations, but you need to be able to develop a tool which allows for apples to apples comparisons between different vehicle categories, recognizing that if you say no to one vehicle, you're saying yes to something else. Which is why we have this particular slide to illustrate is what exactly is an apples to apples comparison. Are we looking at things as a single trip assessment versus a multi-trip assessment? So not from an engineering perspective, but more so from a, what does this mean from the number of trips and the cumulative impact of those multiple trips in order to deliver the same freight task, recognizing that freight task is rarely just one vehicle transporting one commodity, but it's many vehicles across different vehicle types transporting the same and different commodities. And each of those has a different impact on the network and a different impact on the community. So Freight Pass, this is what it looks like, and I'll do a live demo of the tool just after this high-level overview, but we've designed it to be as intuitive as possible and as step-by-step as possible. So the first stage is vehicle selection, and this is where we've tried to break down how do we actually enable users to find and estimate impacts associated with potentially over 11 million different types of freight vehicles you can look at. So we've broken it down to a combination type. You can see the little the little scroll bars on the right-hand side. Fuel type, diesel and electric, to allow for comparisons between ICE and battery electric vehicles. We have a hydrogen vehicle option, which we've currently hidden because there's not enough data available to for those calculations to occur. But once that actually happens, we'll turn it on, have it available for everyone to start making those calculations to understand sustainability trade-offs associated with different engine types. And then there's the PBS vehicle versus the non-PBS vehicles. Once you've selected a configuration, you can start scrolling down on the various little intricacies associated with how many axles, whether or not they're split axles, determining how many tires and the tire arrangements, as well as the individual masses you might like to see on each particular axle group. All of this has significant implications, particularly for pavement wear, and I'll get to that shortly. But the point of this vehicle configuration screen is, especially when it comes to PBS vehicles, masses aren't necessarily consistent across axle groups, and that might not mean much from a freight task perspective when it comes to total volume of trips and total hours on the road. But it's a significant impact on pavement wear because for the engineers online today, we know that each ton increase in mass is not a linear increase in wear. It's an exponential relationship, and just shifting the mass across different axle groups can have different outcomes when it comes to pavement wear. And this isn't just a road manager tool, but in our various communications with industry, we've also basically told them how you distribute your mass on your vehicle. If you're able to distribute your mass on your vehicle, that might mean the difference between a road manager saying yes or saying no to a particular access application, because you've optimized how you apply based on a potential asset management risk appetite that a road manager might have. So this tool isn't just useful for road managers in assessing from a pavement perspective, but also in industry applying on how that might increase the likelihood of a particular vehicle at a particular mass operating on the road whilst doing the least level of damage, and understanding what that damage might be if given the choice to shift things around between different trailers. So besides the vehicle selection, there are scenario inputs. Scenario inputs include, how far you're traveling, the total payload which needs to be transported, whether you're in urban or rural areas, and also the condition of the road. So whether it's windy, there's a undulation, and whether or not the road's particular roughness. This has implications for things like fuel consumption and operating costs, where obviously if something is hilly, a vehicle might might burn more diesel. If a road's rough, then that might have maintenance implications for vehicle operating costs. So all these scenario inputs, mostly drop-down bars, they have a lot of effect on the vehicle externalities. And what this effectively does is it equips everyone with as much information as possible to better understand things, not only from a road manager's perspective, but also from an operator's perspective on what different routes and different road conditions might actually mean for different types of vehicles. So we have the productivity measures, which you can see on the right-hand side. So return trips, journey time, distance traveled, and travel time costs and vehicle operating costs. So they're fairly straightforward. And then we have crash rate based calculations. So these were taken from work done by the National Transport Commission for its heavy vehicle driver competency framework on historic crash rates for vehicles. So basically we've assigned the data and that particular method to this tool, and based on, you can see a 13-ton difference in payload between the different vehicle types. It might be, the numbers are relatively small events, but you can see there's a material difference in the number of trips which need to be undertaken before you're likely to see, as an example, a fatal crash event. So just looking at the number, so vehicle A, that B double versus vehicle B, the A double. For a fatal crash event to occur, you're probably looking at close to 50,000 trips for a B double versus 75,000 trips for an A double. So not only is there a gap in a potential fatal outcome based on historic rates, but based on the volume of the number of trips which need to be made, as a decision maker, you could potentially say, is there a big difference between 50,000 and 75,000? Yes, there is. But even if you're only looking at one particular vehicle type, 50,000 trips is potentially a lot of trips to factor into whether or not an event is likely to occur. And then finally, we have our sustainability based metrics. So decarbonisation and net zero is ramping up. And what's often misunderstood is fuel consumption of different vehicle types. As you change your speed, you're operating at different parts of your engine, and the maths, and I'll go over the sources soon. Basically, at different speeds, different vehicle types have different rates of fuel consumption. And again, the type of road and the type of operating environment has different rates of fuel consumption. So this is very useful. So from a policy and an amenity perspective, in making decisions, in just understanding not only the potential environmental sustainability effects from a diesel and carbon perspective, but we have also noise, pollution cost impacts, biodiversity cost impacts, and all those which you can factor into your decision making as well. So focusing on the pavement impact comparison module of the tool, you can see on the left-hand side, there's 3 different modules. And this is effectively a summary of the key pieces of information which affect the pavement wear results. So obviously there's the number of axles and the axle configuration, but also the tire size can have a material implication on your pavement wear results, such as super single tires. Whether or not a vehicle is fitted with road-friendly suspension is also important. There's been quite a number of studies done over the last 40, 50 years on what air suspension versus spring suspension versus other suspension types might have in terms of the average forces which are applied to pavement. So we've built those into this particular tool and giving users the option of whether or not they would like to consider road-friendly suspension in moderating the potential vertical pavement loading results. And obviously, there's the standard load which is used in all the calculations. The benefit of this particular tool is the maths has been established for quite some time, and if you're a particular road manager which might not have access to a pavement engineer, this is useful to provide you the means to do the same calculations that the engineer would have been able to do. So when we have the results, we've split them into a single trip versus a freight task based results setting. So depending on the vehicle you actually build, because we find both are actually quite important. So you can see here for a single trip based comparison, so vehicle A, the B double without road friendly suspension, comparing it to vehicle B with road friendly suspension. The single trip results will tell you on a per axle basis and on per vehicle basis just how much more damaging vehicle A is relative to vehicle B. So when you look at a single trip, in this case, the less productive vehicle, when we're looking at SAR4, is less damaging than the A double by about 11% on a single trip basis, which is where the freight task comparison becomes important, because as Scott and I mentioned a few times, is you have these vehicles doing many trips. So when we're looking at the asset management longevity over its entire life cycle of a particular asset, once you put it into a multiple trip basis, you can see now that vehicle B, the first measure, payload per ESA or SAR, per single unit of damage, 6.55 tons of payload versus 5.47 tons of payload for the same thing being transported. Or in other words, for the life of the freight task, the B double is only is 0.84 compared to the A double, so it's actually 16% worse off over the life of the freight task compared to 11% better off on a single trip basis when it comes to the cumulative vertical pavement wear. So alongside the payload per ESA or SAR, there are two other ways of looking at it. If you have the data to understand the marginal cost of what it might be to resurface your particular road, you could input those dollar costs in and it'll do the maths for you on how much it might cost you to rehabilitate a certain section of road. And then there's the wear productivity index ratio that I mentioned earlier, of basically how much more or less damaging is a vehicle relative to the other for the lifetime of the freight task. Recognizing that this is a lot of engineering, so what I wanted to really emphasize is the freight pass pavement impact comparison module. It is not provision of engineering advice. Obviously, you should speak to an engineer if one's available. But what it does do is everything which is established in literature and is already publicly available, it's digitized that into a way which enables for self-service vertical pavement loading calculations across different types of vehicle configurations. So how do you access the tool? If you go to freightpass.nhvr.gov.au, it's free to use. There's no sign-in requirements. Feel free to share. This is what it looks like, and you can toggle on and off reference vehicles to show or to choose from in comparison, but it's as simple as choosing your vehicle type, and then you can start modifying each of the different variations. You can see there's very weird things in terms of the axle groups that you can potentially select between the different types of vehicles. And as you make your selections, everything automatically updates down the bottom. So you can start choosing from all possible options and adjusting all the masses. Compare it to any other vehicle you want to choose. I'm just going to randomly choose some things. Makes it really strange. That's the point of the tool, is if you're unfamiliar with a vehicle, you can start building a vehicle and comparing it. And as simple as building it, clicking onto the next screen, changing a few things, just go 700 kilometers, very large freight task, changing the speed, and make something very, very weird in terms of the road. And all that should update in near real time to effectively say, if these were the vehicles you had a choice of comparing, these are the results you were likely to see from productivity measures. A suite of crash rate measures on how many trips are required before an event might likely to be seen based on historic records, as well as calculating what the marginal economic costs associated with those crashes might be. So fatalities, hospitalizations, non-hospitalizations, as well as property damage only events. And then we have sustainability-based trade-offs, so fuel consumption, CO2 emissions and costs, air pollution, climate change, water tank emissions. And then noise, pollution, biodiversity impacts, and soil or water impact costs. So there's a whole bunch of different ways of looking at it. As I mentioned when I started, so this isn't just purely a route assessment tool which you might like to use in order to make an access decision. The outputs are useful for policy related decisions which governments tend to make, and since a lot of these measures have outputs in dollar terms, it's useful for potentially acquiring information which might go into funding submissions to upgrade certain roads or intersections, or even bypasses, things like that. So where did we get all these numbers and methods from, though? In the terms and conditions associated with the tool, we have a suite of data sources. So a key data source that we have is Australian Transport and Planning Assessment Guidelines. So effectively, they're the national accepted guideline, and recognizing that TfNSW has its own specific one for New South Wales too. But nationwide, there are a set of guidelines that establish a consistent data assumption base as well as consistent formula base, which feed into all the various calculations. So we've hyperlinked everything here, so it's as transparent as possible, so any user can actually look at the data and understand how the numbers were actually formulated. We felt that this is important because a lot of similar tools available in the marketplace for other industries, they're basically just the interface with a lack of transparency as to where the data and methods actually came from. So when it comes to things as sensitive as vehicle choice options and vehicle choice related decisions, it was important to be or to have accessible all the various data sources for people to interrogate. Within the user guide as well, we've copied across the various formulas and what the various data inputs actually mean. Again, it just makes it easier to digest potentially hundreds of pages worth of content into what was actually used within the Freight Pass tool. So the final bit is the pavement impact comparison module. You can see it was as per the slideshow I had before. This is just a quick check on what you're actually looking at for each vehicle. So once you've confirmed this is actually what you want to calculate on a per axle group basis as well as the masses, as soon as you calculate the results, you're brought to this screen where you can choose to compare the vehicles against each other. So in near real time, effectively, again, on a per axle group basis, as well as a total vehicle basis, how does it perform on a single trip versus a freight task, the relative performance against each other when it comes to vertical pavement wear. So that's it for me, Josh. Hopefully that wasn't too quick. There was a lot of technical info there.
No, thank you, Brayden. I appreciate that. And yeah, certainly a lot to cover, but as you mentioned, people can get access to that to dive in a bit more detail if they like. So, look, we'll throw it to the audience for any questions that you may have. So please do pop them either in the Q&A or in the chat function. Now, I've had a couple more come through from George, so I'll read those out. Many rural roads have concrete causeways that have a significant dip, but local government does not have longitudinal transverse profiles of these various regional road concrete causeways. Have TfNSW or NHVR taken into consideration these longer and more complex heavy vehicles and I guess the impact on causeways, so decoupling and the like?
Happy to take this one. So we certainly working through in partnership with the Commonwealth from a funding point of view and in partnership with NHVR from an administration and delivery point of view for the Strategic Local Government Asset Assessment Program. Wherever possible, we're collecting data on bridges and culverts if they're required, because that can be the issue. And I think don't quote me on this, I know it's been recorded, but I think we're at about 3,900 bridges / culverts collected in New South Wales so far. And we have done the LiDAR mapping of about 20,000 kilometres of local government roads. So our intent is to try and collect all of the necessary data for the entire road network in New South Wales. When I say entire, it will certainly be prioritised by around that 26 metre B double approved network, because that, as mentioned before, is the primary freight movement in New South Wales from road point of view, and then subject to funding and the ability to then ideally we will collect as much data as we possibly can across the entire New South Wales network. Ideally, that's so that we can make automated access decisions and feed that into the National Automated Access Assessment System. That's designed to try and capture that. I would note those, I think Brayden might have mentioned as well, that the PBS vehicles aren't designed or typically aren't designed to increase axle masses. So any of the impacts that are happening at the moment are similar kind of axle masses. Admittedly, they might have, with multi-combinations, then you've got more axle groups that travel over the structure in a shorter period of time. But every heavy vehicle that you remove out of the task, you're removing a 9-ton prime mover that is adding the impact onto networks that doesn't need to be there. So there's no additional payload carried by that prime mover when it's hooked up when it's removed from a high productivity vehicle combination. So I think we're also making sure that we're comparing against what's the impact today and what's the impact that we're proposing for tomorrow. They're not decisions in a vacuum. And that freight, as Brayden definitely said, still will move in the combinations that are available to people today, and they can be in much more impactful from a network point of view vehicles.
Yeah, great. Thanks, Scott. There's a related question here from Jack. Has there been any work done on the impact of bridge structures, particularly older structures designed prior to modern loads? His comment is, they have a number of older structures in their local government area?
Yeah, very similar kind of answer, to be honest.
Yep.
So that process is designed to make sure that every individual bridge is able to have its individual assessment against every individual vehicle that is likely to, or that will be, it'll see exposure to. Naturally, we are working towards understanding the impacts of, or what a lot of time and a lot of analysis around the impact of vehicles on bridges, how that relates to design guides are different to experience of outcomes from access that's happened over many, many years and varying types of heavy vehicles. So all of that's being taken into account as well. But ultimately, our outcome, our desired outcome is to be able to make an individual access decision for every structure in New South Wales. But I have to underline that is subject to time and funding to be able to collect all of that data. In the meantime, we're kind of faced with the same scenario that we have today. So when you're approached by industry for an access decision, then it might be that you don't have enough information to make a decision, and and that might lead to a restriction for that structure for the interim. But as I said, if vehicles are designed to be suitable for your network, then that opens up alternate corridors that could still enable that vehicle to do the task. And then it identifies for us a structure that requires upgrading and then is prioritised into that upgrade funding process.
Thank you. A couple other quick questions from George. The next one is payload always a good measure for the analysis of incidents and injuries, given a fair assumption that non-agricultural heavy vehicles could be volumetrically loaded? The number of heavy vehicles is based on volume capacity, and the number of trucks may distort payload values. Is there any comments from either of you on that?
Yeah. Oh, sorry, Brayden, I'll let you answer this first.
It could just be me, but I'm interpreting that as the same thing, because even if something is volumetrically constrained versus mass constrained, ultimately it's still a payload thing. So if given, I'm going to be very careful with what I say here. So we have agricultural vehicles versus freight vehicles, which might transport an agricultural task. So I'm assuming this is a question on the latter, that is transporting agricultural commodities, which with the payload densities might be completely different. But ultimately, if the payload density differences are associated with an influence on the volume, there's still a tonnage associated with those particular vehicles, and they might be reflected on a particular application that an operator might have. And that being said, you can still translate volumetric constraints into a mass to compare the number of trips associated with the different vehicles and therefore the impacts associated with those different vehicles. So it's really just that one additional step to translate, if something is volumetrically constrained, what is the upper, or what is actually the mass limit associated with the volume threshold, which peaks first. And unfortunately, the tool doesn't currently accommodate that, but it's something we could look at moving forward if we can try and get a defined list of commodities and the average densities.
Thanks, Brayden.
I was going to say very similar. It's ultimately I see the percentage comparison, because when you talk about high productivity vehicles moving payloads, then you're effectively talking about the same trailers being coupled up in a more more productive combination. So if they were previously loaded based on volumetric, then they continue to be loaded based on volumetric, and you're still removing that 9-ton prime mover from the task. So if anything, you kind of end up with an even greater percentage-wise, because the 9-ton is fixed and that doesn't change and it's not contributing to payload. So your percentages are really where you get that comparison, because we know that heavy vehicles don't always operate at full mass, but you have to draw a line somewhere, and we typically go worst case scenario, and worst case scenario is mass related. So
yeah, right. Thank you, Scott. Last question from George, and we might make it the last one for the day, given we're a little bit over time. Is Transport for New South Wales going to increase the number of weigh in motion sites to allow designers more modern loads from various axle groups from heavy vehicles?
yeah, great question, George. I would like to say that we are doing our best to increase the network-based monitoring. So that will include things like strain gauges on bridges, etc., weigh in motion. We also have rolled out a significant number of machine learning cameras that we partner with mass monitoring wherever we can on corridors to get a better sense of what's moving around. But also happy to say that we are moving towards, particularly for these innovative vehicles, electric vehicles, etc., you'll see that our policy and our notices as they continue to roll out will feature smart onboard mass as well. So where we're making decisions that are prioritizing assets as a service and then using the evidence that we collect from that telematics data and smart onboard mass to make sure that we can prioritize and direct funding and maintenance and inspection schedules, etc., based on utilisation and demand, those data sets come together to form a really powerful set of insights that guide that decision making. So it unlocks access, but it also makes sure that it is very clear where funding needs to flow as a result of demand. And sometimes it can say, well, there's parts of our network that don't really get any kind of measurable exposure from impact to heavy vehicles, and that gives some assurance to asset owners to be able to manage those assets based on the utilization and what's required of that. So I think it's about being smarter in every single step of this process. So how do we get better outcomes without, as I said, increasing costs to either government or industry, without it being offset by significant productivity improvements for industry and for government, minimising those at wherever possible, smarter spending, etc. And then, of course, making sure that we deliver on the policies of the day for the government.
Fantastic. Thank you, Scott. And thank you very much for your presentation today. Brayden, thank you very much for your presentation today as well. We are a little bit over time, so we might just have to wrap things up there. Thank you all for those who've stayed on the call, and certainly we've recorded the session. It'll be made available for anyone who wasn't able to see it today. A quick mention: our next webinar will be held on Wednesday, the 17th of June. So keep an eye out for some details about that one. But Scott and Brayden, thanks again, and everyone enjoy your afternoon.
Thanks, Josh. Thanks all.
Thank you.